Hello, it's Mr. White. I'll be reading from Chapter 5, Lesson 2, Cellular Respiration. My Planet Diary. Going to Extremes. You may not know it, but there are organisms living in rocks deep below the Earth's surface. Other organisms hang out in steaming hot lakes, like Grand Prismatic Spring in Yellowstone National Park, shown here. The water in this lake can be as hot as 86 degrees Celsius. Still, other organisms nestle inside nuclear waste. All of these organisms are extremophiles, organisms that thrive in extreme habitats. These life forms can get energy in strange ways. Some make food from ocean minerals. Others break down compounds in radioactive rocks. What happens during cellular respiration? You and your friend have been hiking all morning. You look for a flat rock to sit on, so you can eat lunch you packed. The steepest part of the trail is ahead. You'll need a lot of energy to get to the top of the mountain. That energy will come from food. What is cellular respiration? After you eat a meal, your body breaks down the food and releases the sugars in the food. The most common sugar in food is glucose, C6H12O6. Cellular respiration is the process by which cells obtain energy from glucose. During cellular respiration, cells break down glucose and other molecules from food in the presence of oxygen, releasing energy. Living things need a constant supply of energy. The cells of living things carry out cellular respiration continuously, storing and releasing energy. Imagine you have money in a savings account. If you want to buy something, you withdraw some money. Your body stores and uses energy in a similar way, as shown in Figure 1. When you eat a meal, you add to your body's energy savings account by storing glucose. When cells need energy, they withdraw it by breaking down glucose through cellular respiration. Breathing and respiration. You may have already heard the word respiration. It can mean breathing, or moving air in and out of your lungs. Breathing brings oxygen into your lungs, which is then carried to cells for cellular respiration. Breathing also removes the waste products of cellular respiration from your body. The two stages of cellular respiration. Like photosynthesis, cellular respiration is a two-stage process. See Figure 2. The first stage occurs in the cytoplasm of a cell. There, molecules of glucose are broken down into smaller molecules. Oxygen is not involved in this stage, and only a small amount of energy is released. The second stage takes place in the mitochondria. There, the small molecules are broken down even more. This change requires oxygen and releases a great deal of energy that the cell can use for all its activities. No wonder mitochondria are sometimes called the powerhouses of cell. The cellular respiration equation. Although respiration occurs in a series of complex steps, the overall process can be summarized in the following equation. Glucose, or C6H12O6, and oxygen, 6O2, yield carbon dioxide, 6CO2, and water, 6H2O, plus energy. Notice that the raw materials for cellular respiration are glucose and oxygen. Animals get glucose from the foods they consume. Plants and other organisms that carry out photosynthesis are able to produce their own glucose. The oxygen needed for cellular respiration is in the air or water surrounding the organism. Comparing two energy processes. If you think the equation for cellular respiration is the opposite of the one for photosynthesis, you're right. Photosynthesis and cellular respiration can be thought of as opposite processes. Together, these two processes form a cycle that keeps the levels of oxygen and carbon dioxide fairly constant in Earth's atmosphere. As you can see from Figure 3, living things cycle both gases over and over again. The energy released through cellular respiration is used or lost as heat. What happens during fermentation? Some organisms can live in the presence or absence of oxygen. If not enough oxygen is present to carry out cellular respiration, these organisms switch to another process. Fermentation is an energy-releasing process that does not require oxygen. During fermentation, cells release energy from food without using oxygen. One drawback to fermentation is that it releases far less energy than cellular respiration does. Alcoholic fermentation. Did you know that when you eat a slice of bread, you're eating a product of fermentation? Alcoholic fermentation occurs in yeast and other single-celled organisms. This type of fermentation produces alcohol, carbon dioxide, and small amounts of energy. These products are important to bakers and brewers. Carbon dioxide produced by yeast creates gas pockets in bread dough, causing it to rise. Carbon dioxide is also the source of bubbles in alcoholic drinks, such as beer and sparkling wine. Lactic acid fermentation. Think of a time when you ran as fast and as long as you could. Your leg muscles were pushing hard against the ground, and you were breathing quickly. But no matter how quickly you breathed, your muscle cells used up the oxygen faster than it could be replaced. Because your cells lacked oxygen, fermentation occurred. Your muscle cells got energy, but they did so by breaking down glucose without using oxygen. One product of this type of fermentation is a compound known as lactic acid. When lactic acid builds up, you may feel a painful burning sensation in your muscles. Lactic acid was once thought to be the cause of muscle soreness. Scientists have learned that lactic acid is gone from muscles shortly after exercising. It is not responsible for the soreness you feel in the days after you exercise. Instead, the soreness is likely caused by microscopic damage to muscles that occur during exercise.